So, welcome everybody. This is the fourth and final workshop in preparation for the City Centre Sustainable Design Housing Competition. And what we're going to do with today is a little bit about space and technologies and materials. So I'll be starting off with saying a few words about external space, and then Brucey will talk for a little while about the NHBRC, and then Isaac will follow on with innovative and sustainable technologies, and then he'll discuss indigenous materials. Right. So what tends to happen quite a lot in architectural design is that people become very involved with the design of the buildings, and particularly the internal space, and they somewhat neglect the external space, which is equally as important. And not only that, but we should be seeking interaction between the two of them. So we should not be, dividing off the buildings from the external space. And what's generally considered is that external space should be defined and contained by a building. So what's the first objective? Well, the first objective is that we are seeking safety and protection of the external space and in the external space. So people have considered that to be a situation where the building runs around the perimeter of the site so that the contained space is protected within it. But we also need to avoid viewing architecture as a barrier. And the great danger with just having this building running around the perimeter is that it becomes exactly that. So some of the things we might want to consider is how we break down this solidity, how we introduce permeability. And one of the important aspects of architecture and architectural design is actually pulling elements apart, pulling pieces of building apart and creating spaces between them. So often when we look at designs, we see all the building crunched up together. And this notion of what's known as articulation, pulling these parts of the building from each other, creates a kind of permeability, it creates breathing, it creates spaces between them. And one of the other things that we need to think about is that we don't just want one enormous space or two slightly smaller spaces. And how we generate interest is by having spaces of different sizes at different scales. And that also enables us to have a variety of uses and to have variation within the space. And all these things create interest. And another thing that tends to happen with external space is that people just view it as being something that is on the ground. And some of it probably is on the ground. Quite a lot of it might be on the ground. But we also need to view external space as three-dimensional design. So does building need to define the site? Do we have to have this building running around the perimeter? Probably not. I showed you this view when I was discussing the form of buildings. And it's because the buildings are actually quite interesting forms. But what they do is that they define a variety of external space. Now, admittedly, those external spaces are not very exciting, but they are clearly defined. And if you remember from the previous workshop, there are also routes that go through these spaces so that the distance between the building closes down and opens up and creates this kind of variety as you walk through it. So whilst we might not be having building around the perimeter defined as big space in the middle, we can use building to define different spaces. A further thing we need to consider is how we introduce structures into external space to define it, and especially small spaces. And this is part of a gradual movement between open space, space that then has a structure to it, and then gradually moving to the interior. So we get this kind of hierarchy of spaces. So one of the things we also want to consider is, is it right to have this abrupt change from something that's distinctly outside to something that's distinctly inside? Or should we be trying to have this graduation as we move from the outside to inside? And I mentioned at the beginning about considering it more as three-dimensional design. So, we can create external spaces with planting, with structures that are raised up in certain places where activity can take place underneath as well. So that gives us much more interest and variety and vistas and all sorts of things if we can raise up some of the external space. And let's get some variety into it. Let's get some fun into it. It doesn't need to be this kind of serious thing all the time. We can have silly structures that are involved. We can have play spaces as well as those kinds of areas that are functional. I think it's also really important to get some focus into the area, and places that are designed for people to actually sit around and have discussions or play games or whatever they might want to do. So if we can create structure that gives that focus for people to come together, then that's a really good thing to do. Generally, there's a lot of criticism of hard surfaces, and rightly so. One of the problems of the development of the city centre has been that we've generated too much hard surface, that we've lost a lot of soil and planting and so on. And of course, the problems of hard surface are that water can't seep away easily, that we create even more heat islands than we'd have anyway from buildings and so on. But that's not to say we should have no hard surface at all. So strategic areas of hard surface, can be really helpful in the design of these kinds of spaces. And then coupled with that, again, we have permeability. We have these arcaded type arrangements. So we're not going straight from the outside to the inside of buildings, but we are creating routes and access in this graduated kind of way. And I hope you can see here also that this happens in a slightly different way on the upper level, where you can get access into the buildings as well. And from that upper level, you can get really good kind of natural surveillance over the area. So you can see what people are doing. You can see if anybody is coming into the space. You can see how the children are playing or whatever it might be. So this natural surveillance from these quasi inside outside spaces, is really important to the design. This is a community garden in Brazil. And the community was actually told at the beginning not to bother because they said, it will get vandalized, it will get wrecked, all the other things that you always hear. But they really look after it, this community. And it's a great asset for them. And they introduce quite surprising activities in it. And in this little corner is this small library where members of the community can go and just, take a book and sit down and read it, which is a great thing to do. And there is great variety of size of space and type of space. These very kind of informal and smallly structured places within the garden. And they create these secluded growing areas, and they grow shrubs and flowers as well as vegetables and other food produce. So you can see what a kind of interesting place this is to be. Another thing we might want to think about is that instead of always considering that planting happens on the ground, we might want to raise up some structures and have planting over the top of it so that we can actually walk underneath it and be sheltered from the heat of the day by the planting. But also this adds to the three-dimensional qualities of it. We've talked about food production at various times, and it might be something which is quite important to your designs. Certainly, it's a well worth thing to do, and it can be that it's grown out on the ground. But this again is from Brazil. This is actually a student project from Brazil, where the student created these structures within the garden, and the structures define the various spaces, but also enabled the food production to occur at different levels within the structure. We've also talked a little bit about the river that runs through the site and how it should really be perceived as an amenity, and whether it can be reduced in size and dominance, and how it might become more of an amenity in that way. But also it's about how we cross the river and the design of bridges that there might be to cross from the outside of the site to more of the sort of interior of the site. And how we think of bridges as being, again, at different scales and different levels of formality, and how they also become part of the design. Okay, so that's just an introduction to external space for you to follow on with. I haven't put any references in today, but you might want to look up how gardens and communal spaces are conceived in different parts of the world. Right, I will now try and stop share and ask Boosie if she'd like to say a few words about the NHBRC.
Thank you, Bob. Good afternoon, everybody. My name is Busiswa Mlandu from the NHBRC. I just thought it's important, before my colleague Isaac takes you through his wonderful presentations, that at least everybody has a background about who we are and why we exist. The NHBRC is a regulatory body of the Department of Human Settlements. Our sole role is to make sure that there is quality assurance in the home building industry. So we are responsible for the registration of all the builders in the country. We are responsible for the quality assurance, where we actually dispatch our inspectors when construction happens from foundation to roof. We are also responsible for the enrollment of the project. So if there's a developer that wants to build a project, everything has to be approved by the NHBRC. So we are very, very, very strict on standards, which we work very well with the South African Bureau of Standards. We've got a Bible for the construction industry that we call the Home Building Manual. It's a guideline for all the home builders in the country. But just to zoom in into this particular competition, the NHBRC found interest because we've got a department that is called the Center for Research and Housing Innovation. Now, in this department, we have a memorandum of understanding with various universities in South Africa, where we've got different projects that we share with, but also to make sure that innovation, we are also part of the innovation, we're part of the green building, and that, we share notes with academia. And if there are any innovation, ideas that are coming up, we are part of that, and that we support the universities. So we felt that it was important that NHBRC, as a regulator, Bob, you just spoke about the city spaces. For anybody to be able to, for example, have that little library in the corner, or a house that has a bridge running, or rather a dam running under, we are responsible for that. We've got partners such as your South African Council of Architectural Practices or Professionals, SACAP. We also have partnerships with SIA, South African Institute of Architects. So we thought it befits to be part of this competition. I'm sure it has been told many times that we are the main sponsor. We take pride in what you guys are doing. We are encouraging, we are supporting, we work very well with the University of Pretoria. We work very well with the NMU University, WUM is also part of this. So we are looking forward to being part of this. The NHBRC, as a statutory body of government, takes pride in this competition. And we look forward to looking at the various creative submissions from the students, and we will support where we can. And we will be with you throughout the competition, right up to adjudicating and the awarding of the prize. So good luck to everybody. And thank you very much for affording us the opportunity, Bob, Jeremy, and the team. And we look forward to being part of this. And I'm going to hand over to my colleague, Isaac, who will take you through the two presentations on innovative building technologies as well as the indigenous systems. Good luck, everyone. I'm gonna dash and go back to my laptop so I can be able to chat to check everybody who's presenting. Thank you and good afternoon.
Thank you, Lucy. And hello, Isaac.
Yeah, good afternoon, everybody. My name is Isaac. I hope I'm visible. Today, as on this last workshop, I'll be taking you through innovative and sustainable technologies. The department that me and Busi working at NHBRC is called Center for Research and Housing Innovation. So I'm working as a building specialist. approving all the technologies that are coming to the country that have been used, doing assessment, inspections, and also training students and so on. So I will go through my presentation. I think I will, can I share it immediately? Or
Yes.
let me just go through it. Yeah. Oh. Start at the beginning. Yes, there it is. So my presentation will be all about the topics that were mentioned: embodied energy, efficiency of systems, and energy usage, water quality, usage and conservation, materials, management system, durability and maintenance, and social acceptability. Now, what we did here at NHBRC, if I need to mention to the students, we have a place called the Innovation Hub, whereby people come in with different technologies and build houses, and then we monitor them from there. So it's situated somewhere in the north of Soshanguve, north of Pretoria, and some of the houses we build around the country. Now, one of the things that drives us from the NHBRC is the constitutional mandate that everybody has a right to have adequate access to adequate housing. And beyond that, South Africa is a member of the international community, the National Assembly. So into the National Assembly, you get this Article 25, where it says everyone has a right to have a standard to a living. Now, this drives the NHBRC technical department to make sure that whatever buildings that are being put, they do meet the constitutional requirements, and also they do address the human right issue. So we work based on that. So something like this, it's totally unacceptable in South Africa in terms of what the Constitution says, because it's a structure, but it's dark inside. You know, a lot of things are not happening correctly. So we try by all means to avoid such structures and make sure that people get habitable spaces. Now, the other thing that drives us is the law. We have what we call our building regulations and other acts that we have. Now, within construction of houses, there's 3 pieces of legislation that are very important. One of the legislation is the building regulation, the Building Act, and we have the Housing Consumer Protection Measures Act. That one is the one that owns by NHBRC, because for every person who receives a house must get a protection against harmful things and houses that are not being built correctly. And the third piece of legislation is your health and safety. So the students needs to be aware of this piece of legislation and to say how is it going to assist them. Now, as they're going to design whatever materials, whatever systems they'll be using, they should be aware that there should be functional requirement of every material and a performance requirement. Now, for functional requirement, they need to check into the standards, South African national standards. There is a collection of them. And then there are materials that are not standardized, that are unique, probably come from overseas. Others are just manufactured for a particular purpose. So those materials, they need to go through testing and certification. Then that's why we call them rational design or fit for a purpose. So I'll talk more about this issue. So it's very important that students know which materials and how to use them and where can they get them. Now, in terms of embodied energy, or what student needs to know or understand is that where do they get their materials, and how can they dispose them in terms of carbon emissions, which materials got the high carbon emissions and which ones got less, and in terms of productivity and so on. So it will assist them to check, and then they can access the software called Edge, the Edge software, of which is a web-based software, and then it will guide them in terms of choosing correct materials with less carbon footprint into this competition. Because one of the things that we're trying to do is also try and reduce carbon footprint in materials. So the use of Edge is just outlined here. It's for them to get used to it, and then you just go on the website, you register, and whatever material that you choose, it will tell you what is the carbon footprint, and it will tell you the durability of materials, how easily materials can be separated, the use of locally sourced materials. So it will give you a score in terms of the performance of the materials, because now they are open to all the materials that they can be disposed to. And then the third thing is that in terms of the energy, when we look at the energy on a house, I just borrowed this structure from one of our a lecture that we had, that in your walling system, you lose about 35% of your energy. You lose 25 on the roof, you lose 15 on the floor, and 15 on your windows, and 10% on your fenestration. So as they design these buildings and then incorporating the issue of energy efficiency, because in South Africa, it is compulsory to comply to energy efficiency rules. So as they choose these materials using the Edge tool, they'll be able to choose the materials that are lighter, that has less embodied energy, in order to come up with a sustainable, affordable products. So you look into the components that they'll be putting in the house. It also plays a major role after the design from the architect side to say what type of fittings do I put? Do I put a geyser or a heat pump? Do I put LED lights or filament lights? So it will guide them in terms of choosing the materials to make a sustainable house cheaper to build and cheaper to maintain. So they will have to look into those elements as well. Now, the other things that I wanted to talk to students about is that every technology in South Africa, it's not one size fits all. So we having about 6 climatic zone. In fact, I think we added 2. We have 8 climatic zone, and then Pretoria, I think it is in zone 2, if I'm not mistaken. So whatever materials that they will be choosing, they should be looking at the climate, because in NHBRC we have tested that some of the materials perform badly in certain regions, in certain climatic regions. So they need to look into those materials with high condensation, overheating and so on. So it is very much important. We have the analyzer, of which is owned by the CSIR. So this is the map of South Africa for climatic regions. I believe architectural students are familiar with the map, and in terms of calculating the energy efficiency in terms of this map. If you look at Pretoria, I think Pretoria is situated in zone 5 now. Yeah, it's under zone 5. When they do their calculation, it's low to medium climate. So they'll be choosing material based on that climate. And this is the embodied energy of materials. So as they choose their components, your concrete's got high embodied energy. Your steel, your wood's got less. So whatever design and whatever material they will be using to build this sustainable, innovative building, and they had to look into the materials that they put in. At the end of the day, we'll have to calculate the total embodied energy of that project, and the lesser, the better, instead of having a high embodied energy. Now, we have approved building systems Mostly these are walling systems. We have light building systems, which are being categorized as A, of which is your steel frame. We have your light building systems combined with steel frame and insulated foundations. We have panels with lightweight concrete. Then we have hybrid systems where you combine the two. Then we have heavy weight systems, of which is your concrete system. So most of the time, I like to classify A, D, and G, or A, D, and F. Say if you work within those three, you are able to come up with a better system. But mostly the hybrid system performs better. And then if you look into our energy efficiency regulations, we have SAST 10400XA, which regulates the optimization or the rational design in terms of energy efficiency in calculating the heat that's coming through the wall, that's coming through the roof, that's coming through the ceiling, that's coming through your floors and so on. So if you check the category of the walling panel, you find that your category, your hybrid system, probably it's in the middle, because your category A, it's very lightweight system, which might have problem in terms of overheating and in coastal areas. And then your category E, your prefabricated panels or your heavy structures, they can perform better in hot areas where you've got thick walls. You take a look at the Union Building and the Pretoria Station. Those are historical buildings of which students can also go and visit how they were built prior to the incoming of this technology, because those buildings are still performing very well in terms of energy efficiency. So it will be good to have reference buildings into this competition. Now, when you look at hybrid systems, they've got a very high embodied energy, but they are suitable for all climatic zones. And then you look at your lightweight systems, which mostly can be monolithic. They have a very low embodied energy because you can use only one material as a wall and as a roof, or even as a floor. So it's got a very low embodied energy, and it can work in many climate, but it will have problem with high thermal performance. And then your precast concrete, it also have a very high embodied energy. It's not suitable for all climate zones, but it's got a very low thermal performance. So you take this table, it might guide you which type of system do you want to use as an architect or as an engineer in order to come up with a sustainable and innovative system. You look at the components under residential, you know that heating takes a lot of energy. So that's where you're going to bring a lot of innovation in order to reduce this amount of heating. So instead of using your normal geyser, you can use your gas geyser or your solar geyser or other methods to heat water, or maybe a heat pump, in order to reduce the amount of energy required to heat the house or heat the water and make the house warm. So it gives you a guidance to say, where can I innovate? Where can I bring improvements? So heating is one of the biggest problems. And as you can see, we have problems with energy in the country. And if we can reduce the amount of heating, if we can build self-heating buildings, then we can reduce the usage of geysers and so on, because the house doesn't need heating. It's self-heating itself. So we can talk about the net zero project and so on. So, but this graph guides the students or the competitors to say, where do I need to innovate? In terms of quality, it is expected that we comply to international standards, ISO 9000 and 9001. But in terms of structural integrity, students should be aware of SANS 10162 and 10160 in terms of structural integrity, and in terms of your walling system, please comply to Part K of the South African building regulations, Part K, which talk about how the wall should be. So all these things should comply to a particular certificate that it's approved. In terms of structural integrity, the structure that the students will be designing should have a minimum lifespan of 30 years when you're using the standards. And the materials should be durable, should be resilient, be capable to withstand harsh environments. Although Pretoria is slightly warm, it's a warm condition. So whatever material that they will be choosing, they should be able to fit the climate of Pretoria in terms of the use and so on. And in terms of emergencies, if you were to build emergency structures, those materials should be able to withstand issues of fires and things like that. In terms of social acceptability, one has to look into the culture of the people of Pretoria, of which mostly is the Sotho-speaking people, but Pretoria has much evolved into a modern city. So it's very much important that the style that they'll be using is attractive to the people. The people of Pretoria can identify with the style of the design and the functionality of such houses. They can be able, there's new buildings that have been built in Pretoria. So whatever they design should fit within the social environment of Pretoria, especially if you move towards the east, because if you're moving towards the city center, you get those old historic buildings. But as you're slightly going out, then you start to get modern designs within the Pretoria region. So that's what the students need to look into when it comes to innovative and sustainable technologies. And the other thing that they need to understand is that there is Agrima SA, which can be able to assist them if they need more information on innovative building systems. And also here at NHBRC, not knowing if I'm breaking the rules of the competition, we can also give much information, not to do the competition for them, but give them guidance, give them the types of technologies that are available, that have been used previously. They can be able to visit houses that have been built using technology. So I think this is the end of my session 1 on innovative and sustainable technologies that needs to be used. Thank you so much.
Right, thank you, Isaac. Are you ready to move on with the second presentation?
Yes, I'm ready to move in with the second presentation. Let me just close this one. Okay. Okay, on the second presentation, I'll be speaking mostly about indigenous materials. This is just an article to say that we're having a very huge backlog on housing. However, the majority of people in South Africa are coming from the rural areas, and in the rural areas, they have built structures. But the problem is the structures that have been built in the rural areas do not conform to the standards. So there is an issue of trying to come up with ways to standardize such constructions. So these articles just speak about that. These are some of the cultural buildings that you find not only in South Africa, but in the whole of Africa. At the top left there, we've got sort of the Zulu beehive, and then at the bottom, we have the Ndebele sort of architecture, of which is closer to Pretoria. And on the bottom left, you have the Moorish, of which is the one used in Morocco and so on. And yeah, in the center, you have an Eli, of which is used in modern Lapas and so on, gazebos and so on. So these are the indigenous architectures that exist in the country, and most of them are still being used. This is just another article talking about this type of construction. In most cases, is twofold. Others do comply to energy efficiency, especially the what we call the rondavel is still performing well, but others, you know, the building shacks and so on, it's not performing very well, and it's prone to destruction by weather and so on. So we need to look into those structures. And then you look into energy efficiency into the rondavels, how people live. As you can see, the more technology advances, is the more also culture advances as well. So we're moving in a situation where we're going to combine technology and culture together to come up with beautiful structures. If you look at the bottom structures there, these are all traditional architecture, but built in a very modern way. They just harnessed the traditional way of building and come up with contemporary styles and so on. So students need to look into such buildings. We have monolithic structures, convention of some sort of a containers into new buildings and so on, or conventions of old building into modern designs. So they need to look into the materials, and they need to look into the design. How does it fit together? If you look at the structure on the top right, it's an ancient English style, but it designed in a modern way. So they need to look into indigenous materials, things like your thatch, your wood. In fact, those are natural resources, you know, natural materials that can be resourced and then regrown again, in, you know, reduced. In fact, they've got low embodied energy, because when you talk about indigenous material, one item that you look at is low embodied energy, because what the people do in the previous, in the Easter years, they never bought any material. They develop the materials where they live. You know, they live with nature. They know the type of wood to cut in, you know, in the forest. They know the type of grass to use for flooring, and they know the type of soil to use for plastering, for preservations, and so on. So they live with the environment without burning or causing any carbon footprints. So that is the idea that student can tap into, say, what do we have here in Pretoria that we can use? Do we have grass, or do we have a factory manufacturing sheeting here and there like ISCO, or what is it available around so that they can use to develop these structures? Your monolithic structures, you know, conversion of unused containers. It's another thing which brings technology into the current waste that we have, because the other thing that we're going to use is to take also what is waste and try to convert it into a usable, sustainable materials. And then in terms of the roof, I've put the structure so that you can see your structural design of modern structures and how the thatch roof structures were designed, and how they gave space, the volume, and so on. So it will help also the student in terms of the design of the buildings, in terms of your steel and roof structures. It also relates to say how did the Zulu nation design the dome, without using steel, but using wood? How did they bend that wood? What sort of wood did they use to come up with a beautiful, if you look at the top right, top left, it's still under construction, but you look at the other bottom, it's nicely done, like an igloo. Although in South Africa, we have these, we don't have the igloo. Like Bob there in Scotland, maybe you might be having those ice houses. Here we've got our nice grass, beautiful houses. If you look at them, nicely done, with perfection. So a student can also look into that, say, how do I perfect this? How do I bring about bigger new structures? I would like to refer to the Mpumalanga Legislative Building in Nelspruit. It's a very huge building, but it's built using the modern African architecture. So they can also tap into that. They can build beautiful domes, big domes, resembling the culture of the area. You see, and thirdly, you look at the structure. Currently, this is what is happening in the homelands in the country. People are using straws and mud and wood. They don't buy any materials. But the problem with this is because it's your water penetration, is your degradation in terms of moisture going in. So we need to come up with structures. I know of a system that improved from this one, of which I will show you as we go by. This structure here, it's made of wood. This is a similar structure, but this time they used mesh wire to develop this type of house. Then they use cement, and then at the end of the day, you get a structure that you can identify with. This is another structure where they use steel and boards, to come up with affordable housing. And these boards have been thermally proofed for fire and water penetration. So you use, what you can see, what is available, but make sure that it is also certified. Then you have another technologies that you can use called a twin wall technology, where you do your scaffolding and your cladding. Then you pour concrete in between. Then you come up with a structure. Then we have the volumetric. These are prefabricated panels. These are falling under category G on that list of mine that are of technological walls, which has got a high embodied energy, but you've got less energy efficiency. Then you've got volumetrics construction, whereby you can design on site and in a factory come and just place on site. You design off site, then you ship to site and just build structures. One of the things is that you can do with containers, or you can do with windy houses. You can build them in a factory, then ship them to the site. You can use any material. Then we have insulation. And on the insulation, we need to look not only about heat insulation, we need to talk about acoustics as well. Depending on the type of structure that you're doing, get to understand the type of material used for acoustics. I've just designed, put a table here, of which I found on the web, that can assist the students to know that for which element, if you're doing a wall panel, which type of insulation do you need? If you're doing your roof, which kind or type of insulation do you need for your roof, and also for your foundations as well? And this will be able to assist you, because in some instances, just that Pretoria doesn't have a high condensation. If you are building in the Eastern Cape or along the coast, you will have to think about condensation. So the students are more likely to be working in a climate which can take all materials, so to say. Pretoria, it's moderately warm. So you can use any material in Pretoria. That's the beauty of Pretoria. And the climate is very good as well. So students have an abundance of materials to use in the area that we spotted for the competition. But for whatever material that they use, if it's not SABS approved, it should be Agrima approved. And this is the companies. Agrima South Africa is a company that was working with the CSIR, but now it's independent. It's working with us, NHBRC. Its function is to test and certify materials that are not standard. So for whatever materials they are developing, they can test it at Agrima, but the test might take long, or they can test it at any nearby lab and then relating it to a particular standard. We'll be there to advise on how this process goes, because in this certificate and this certification, it will tell you whether that material is good for what type of a building, because not all materials are good for housing in South Africa. We are very selective with materials. So when you come from Agrima, it will tell us this material is good for places of instructions or small shop or offices or dormitories or whatever. They should be aware, and they should be know that a container is not a home and it's not a building. It needs to be converted, and conversion through calculations. You need to calculate all your energy, your thermal performance, your acoustics, and all these other things. So you have to do a rational design and prove to us and put insulation. I was happy when this thing had the issue of insulation, because that's where the problem is. So when people bring material, they forget the issue of insulation, and buildings tend not to perform for the required output. But all in all, that's how my presentation goes. This is just a certificate on what Agrima test. They test behavior in fire, structural performance, water penetrations. So they'll assist you in looking at those materials and how they perform. So thank you so much for giving the opportunity to present about indigenous materials, and also for innovative and sustainable technologies that can be used within the competition. Thank you so much.
All right, great. Thank you, Isaac. Yeah. Right. So now we'd like to move on to any questions and comments. And if you prefer, you can do this through the chat, which Francine will coordinate. So we're welcoming questions on anything you've heard today, but also, as this is the final workshop, really anything at all about the competition that you'd like clarified or help with. So have we got anything, Francine?
Nothing on the chat yet, but I have a question for everyone. Have you done a test print of your submissions yet? Have you completed yet? How far are you, and how is it going? Does anybody want to venture? We have dead silence, so everyone is still very busy with their submissions, which is fantastic. We are still in the design process phase. We are cooking. That's a good question. Comment. This is from Victor Mukaba from TUT. So very good. No, that's good to hear. I just want to say, Isaac, that was exceptionally informative. And Prof. Bob, what a wonderful presentation. Thank you very, very much.
Thank you.
No, any other questions? Does anybody have questions with regard to the submission? I can quickly touch on the process. The process will be every group will receive a code. We had a few architectural learning sites requesting codes, and then you will submit the work via WeTransfer or Google Drive transfer to the website, or not the website, the email address on the brief. So is everybody okay with that process? Do I have any questions regarding that process? I've got a few thumbs ups. So
Yep.
it seems everyone is okay. I'm actually, along with Prof. Bob, we're looking at the submissions. Prof. Jeremy is in charge of the judges. So he's extremely trustworthy and an honorable person, but please do not share your submissions and your names with anyone except for myself and Prof. Bob. So just to keep it all fair, yeah, and then we can't wait to see your submissions. We are so excited to see what comes from this workshop and from the competition at large. So any other questions? Isaac, any comments from you? Prof. Bob, comments from you?
No, I don't think so. I'm just interested to hear anything from the participants. So either participants, everything is just so totally clear you don't need to ask anything, or you don't understand a word of it, is one or the other.
We actually have a question. Someone is asking, Jeanu Raoul, just to clarify, there is no link for us to register our groups in as of yet. Am I right? Because the only links available were the ones for the workshops. Okay, so there's quite a few links available. On the brief, you will see there are links available to the site information, the drone information. I've actually added site information drawings. I've added DWGs and DXFs of the site and the locality. And then, yes, links to the workshops. But that website, or not website, the email address, CIB Sustainable Housing Competition at gmail.com, that is where you submit your project to. Now, in the bottom right-hand corner, as per the brief of your submission, you will be required to place a code. We do not want any identifiers on your project. We do not want to know your names on your project or which university you come from on your project. So that 3-digit code you will either receive from your lecturer or directly from that Gmail. You can email me on that Gmail. If you are someone who is doing a project outside of your coursework from an institution where it is not an in-studio run project as part of your syllabus, please do email me and I will give you a code. Does that clarify your question, Janine Rule? Very good. Thank you. Thank you. Thank you. That was a great question. I think people might have been wondering about that. And from that email, from that Gmail, every single submission, you will receive a acknowledgement of receipt email back. And yeah, from there, the work will actually be printed with another partner, Bogertman and Partners, who have been generous to sponsor the printing. So that saves you from printing costs and courier costs. So please be mindful of your PDF files. I will not be able to print anything but a PDF file. And be mindful of the size as well, so that we are able to spool it and get it through the system. If you won't be able to print it at a postnet or a printing facility in your own time, in your own town or city, then there is a large probability that I will not be able to print it at a architectural organization. So maybe do a quick test print at home as well, black and white, which is far more cost effective, and just check that it can go through the printers. Anyone else for a question, or do you want to get back to cooking? Cooking your projects. I think that's lovely. Okay. Well, I'm going to do just a quick promotion of the CIB and the NHBRC. Definitely look at the resources that the NHBRC provides. It's really, I think we saw from the presentation with Isaac that for information with regard to housing in South Africa, but also do consider joining more events from the CIB. We have a webinar coming up. I'm going to put the link in the chat for anybody who'd like to copy it. It's webinar for anyone interested in academics or academic research. I can personally recommend any activity of the CIB for academic progression and research progression. And then I see Dr. Judith, I have your hand is up. Would you like to ask a question?
Yes, thanks so much, Karen. There's actually a question in the chat, which I think we've missed.
Here is, I've got it. Yes, ma'am. Thank you. On those buildings. Currently, we unfortunately do not have any surveys of the plan. We only have the drone footage. The drone footage, there was some 3D drone footage done. I can put that in the folders as well for anyone who would like to 3D model it out. But no, we have no plan. What I would recommend, and Prof. Jeremy will also give me his views, but I would recommend that you infer what you think is in the building. And what you infer is the structure that you keep or the structure that you remove. And to tell us how you infer that structure would look on the inside. And Jeremy?
Yeah, I think it's a very good question, particularly around mixed use and sustainability. The one building has got quite a lot of glazing, so you can actually see quite a lot of the structure and infer how that would work. The other couple of buildings are very typical load-bearing walls, etc. So I think you just need to kind of infer how the sorts of spaces that there may be inside those buildings. But yeah, it's a good, certainly a good question, and I think that's all we would expect. We wouldn't expect more than that. And you know, there'll be a degree of interpretation of kind of how you think those buildings were laid out.
Yeah, no, definitely great question. So to just remind everyone, we're looking for ideas. We are relying on you to fill that gap between what is known and what we still have to explore to solve the sustainability problem and the housing problem in South Africa. So any concept that you have is relevant. Any idea that you have is relevant. And I'm not a judge, but I would speculate that those concepts that are best developed and best presented will probably, there are so many prizes thanks to the NHBRC. So it's a generous amount of prizes. And I think the best developed projects will be walking away with them. Those are my thoughts.
Yeah. Can I just say something about the buildings? Because of course you can keep all the buildings. Of course you can keep some of the buildings. But I would say to you, don't compromise your proposals just to keep the buildings. You know, it's totally legitimate to remove them all. It's totally legitimate to keep them all or a proportion of them. It's just whatever suits your scheme the best.
Well said. Yeah. And then, of course, if anybody infers the building, I will definitely take a look of what's inside. But yeah, it's only weeks left. I think there's 6 weeks left until submission, or five weeks left until submission. So there's plenty of time to take concepts and develop it further. Yeah. And then, of course, group work. Work to your strength. If I can give advice, work to your strengths. You know, there's this joke that I should perhaps not tell in a recording, but there's this joke that says, what do you call 2 architects around a table? And the answer is 1 architect too many. And I've noticed sometimes with group work that comes into play where there's so many different ideas. But once you streamline a group to work to everyone's strength and everyone gets a specific task that they resolve, then those are very well. So, yeah, especially if you have 2 individuals whose projects are very similar, pool your economies or your capacity, have economies of scale with regard to your capacity. That's my recommendation to you. Don't be scared of group work. And then, yeah, if that is it, Prof. Bob, Prof. Jeremy, Isaac, any closing words?
Well, I think just what you said already, Francine, that we're looking forward very much to see these proposals. Sadly, I won't be in Pretoria, but I'm sure the exhibition will be absolutely fantastic. And you know, good luck, everybody.
I think that the same from me. So please do send an email if you get a question or anything like that. And we'll just make sure that you get a response. And if it needs to be shared, it will be shared with everybody. So that's the first thing. The second thing is there is a brief. And just like an exam, the brief is what you should use as the basis. We've tried with these lectures, I think, to kind of stretch and give you additional ideas and new ways of doing things, but ultimately the brief is what matters. And there's 2 or 3 things around the brief that are quite important. One is that it's about ideas. And that's important. So think about what an idea and a new way of thinking means and how you share and present that. The second thing really is something I think that Bob said. He said, you know, like a bit of writing, like a design, there are only a certain number of ideas that you can load onto a particular design and approach. So don't overload the designs. We've deliberately provided a nice diversity of prizes. So there's things like social sustainability, which you very rarely see. Normally there's just a first prize, a second prize, a third prize, and it's architecture. We've deliberately included one around social sustainability. I think there's materials, etc. So there's a nice opportunity to kind of really think through what that means and then target it and kind of go for a particular niche. And that's deliberate. We want a diversity of approaches, a diversity of ideas. And so you look at the brief and think through that. And I think there's always a kind of mixture of kind of content and detail and rigor, and then how you share it, the interface, how you present it. And I think architects normally are very good at the second bit. The first bit is not quite so strong. Isaac is nodding his you know there, and it's about the thinking, it's about the research, the science, and the CIB is a science organization, so we're definitely interested in the first bit as well as the how you present things. So I think that's it from me, and good luck, and have fun. It'll be a I think it should be an interesting exercise and something hopefully that you can have in your portfolio as you look for your own work and work with others. Cheers.
Yeah, thank you very much.
Thumbs up.
Yeah, good luck. And thank you everyone for joining us. Yeah, thank you. It's very encouraging.
Yeah.
And then Prof.
Yep.
Bob.
Great.
Good.
So
Okay.
back to the cooking then, is it?
Yes, it's off to the cooking. It's off to the cooking. And the rest, we have to wait for 5 weeks until we see it.
Yeah, baking. Okay, bye-bye.
Yeah. Great. Okay. Thanks all.